So in simplifying algebraic expressions, we start with something kind of complicated, then we're going to follow our order of operations, and then combine any like terms if we can. So terms I brought up before as these pieces that are separated by addition, subtraction. So if we have this expression right here, I could separate the terms 20 as a term, I have addition. Now even though there's subtraction here with the x minus 2, it's separating terms within the parentheses, but since that's all contained, really our second term is this whole 4 times x minus 2. And then we see subtraction, and then we have this third term here. So we can see these separated terms. What we would want to do in simplifying is follow our order of operations. So like I would look at parentheses, where I have this x minus 2. I can't simplify that any further. These are unlike terms with a variable and a number. I would look for exponents, where I have this x squared, but that's completely simplified. I don't have anything to apply to since it's a variable. Multiplication division though, I do have a step where I can simplify here because I have this 4 times x minus 2. So this is going to use the distributive property where I'm taking this positive 4 and distributing it into the parentheses there. So it's going to multiply with each term within those parentheses. So what that next step would look like is 20 plus 4 times x plus 4 times a negative 2, which is negative 8, and then minus 3x squared. So order of operations, now I don't have any parentheses, the exponents are all simplified, I don't have any multiplication or division to carry out, but now I could look at addition, subtraction, and this is where I look for like terms. So like terms are terms that have the same variable factors, meaning they have the same variables and the variables have matching exponents. So even though we have this 4x and 3x squared, they have the same variable of x, but the exponents are different. Here we have an exponent of 1, here we have an exponent of 2, so those are unlike terms, so we can't combine those together. What I could combine together though is this 20 minus 8. So this would be the same thing as 12 plus 4x minus 3x squared. And now that would be completely simplified. So it's in this addition subtraction stage that we're looking for like terms so we can combine them together. And what we just used, there's this term here, constant term, which is just a number. And that's what this 12 is in the simplified form. That's the constant term. Okay, so let's try this out with a few examples here. So in terms of simplifying, no parentheses, no exponents, no multiplication division. So we're just at that addition subtraction stage, which is where we start looking for like terms. So for like terms, I have this negative 12x and negative 8x. And let's just focus on those. Again, you may know how to do this very well, but we're just reviewing, so I'll go into detail for those of you that need a refresher. So what we end up doing is, so the variable piece stays the same. So we're going to have this term with x, but what we need to figure out is the number in front of x, this numerical coefficient. And what we do is we combine the coefficients. So what this would really look like in terms of a calculation is we have negative 12 minus 8 of these x values. And then we could even do the same thing for y. We have this positive 5y, positive 20y. So if I just put a plus in between there, what we're really doing is taking 5 of those y's and adding 20 of those y's. It's kind of like I had 5 apples and I'm adding on 20 apples, so I end up with 25 apples in the end. So the apple piece doesn't change, so we don't want to change our variable because it's staying the same thing. So negative 12 minus 8 is negative 20, and x, and then plus 25y. And that would be completely simplified. We can't combine these because they're different variables, so it's like we have apples and oranges. So no matter how we made a sentence with them, it's like we have negative 20 oranges plus 25 apples. We can't combine those together. All right, this next example here, looking for like terms. So we have x in each term, but the variable has to be, the exponent has to be the same too. So we have this x with an exponent of 1 and this 18x with an exponent of 1. So this is like having 1x plus 18x. So we're combining those numerical coefficients, and then that 20x squared doesn't have anything to combine with, so it just stays off to the side. So this would be 19x minus 20x squared. All right, our next example here, we are going to look at the parentheses, but there's nothing to simplify within the parentheses since they're unlike terms. We have an exponent, but there's nothing to simplify with that. So then we're going to look at multiplication, which is occurring with those parentheses there. So we want to distribute 9. So we'll have 9 times y plus 9 times 2, which is 18, and then minus 3 plus 5y squared. So I'm going to look for like terms, which are only like terms are these constants. So I'm going to have 9y plus 18 minus 3, so that'll be a positive 15, and then plus 5y squared. And that's completely simplified. What we're seeing here is a quadratic expression, and what you might be comfortable with is putting this into standard form. And what standard form would be here is just rearranging the terms so that the exponents decrease. So we would start with 5y squared plus 9y plus 15. Both of these are completely correct answers. Just sometimes when we get to working with quadratic expressions and equations, it can be helpful to put it into this form for certain calculations. So I like to show it just to kind of start that habit going. But if you plug this in as an answer, it's completely correct too. All right, our last example here, we have 2 multiplication pieces. So we have this expression 4x. So that whole piece is going to distribute into the parentheses. And then we have a negative 4, and that's going to distribute into parentheses. So we have 9x out front. We have a positive 4x times 2, so that's a positive 8x. We have a positive 4x times 3, which is a positive 12x. We have negative 4 times 2x. Okay, I'll come back and show you another way to do this too, because I did kind of skip an order of operations, but this will work out the same. Negative 4 times 2x is a negative 8x. Negative 4 times positive 3x is negative 12x. And what we can see is we have this positive 8x and negative 8x. So it's just turned into 0. Same thing with positive 12x minus 12x. Those turn into 0. So what this will simplify to is 9x. Now where I caught myself there, and this, I'm going to say this so many times in algebra, there are so many different paths to the same answer. And whichever way gets you to the correct answer, as long as you're following algebra rules, it's all good. What I could have done is simplify the parentheses first. Notice how I could have added those together, and that would truly have followed order of operations. So what that would have looked like is 9x plus 4x, and then in parentheses would have been 5. And then minus 4 times parentheses 2x plus 3x would have been 5x. And then I would do multiplication. So I have a positive 20x and then a minus 20x. And then I would see that same thing where those would just turn into 0, and I'd end up with 9x. So even though I didn't simplify those parentheses the first time, you'd still get to the same answer. It's just a little more complicated getting there, but same answer in the end.